Alright, this video covers some of the assignments we did in class on, what's today, Monday, October 1st. And I had to go through it kind of quick, and it's pretty complicated, so I wanted to just take an extra chance to describe some stuff some more, and maybe go a little slower. So once again, video 12 covers these topics. And this is kind of an extension, so you should have watched topic 12's video already, and then if you're working on the assignments, which was 27 and 28, and that's on page 69 in your text, and then 30 through, I don't know, 37-ish on page 71. So I'm going to go through a couple of them just to kind of give you some more support. So let's take a look. Let's figure out what we're trying to find here. We know this car accelerates at a constant rate. Put this down here in the corner. Car accelerates at a constant rate, so acceleration is constant, not velocity. And it goes from this speed to that speed and travels this distance. How long does it take to achieve this speed? So we want to find time. Time's what you're looking for. We know velocity initial is what it starts at, from 15 to 25, that's our final. In a distance, a change in distance of 125 meters. Now I've got two formulas that have time in them that I could use. I have velocity final equals velocity initial plus acceleration times time. And I have distance final equals distance initial plus velocity initial times time plus 1/2 at squared. Now in both these examples, I don't know acceleration, nor do I know time. As soon as you know two things, you can't use a formula. But what we can do is I do have enough stuff to solve for acceleration by itself. And once I solve for acceleration, then I could use either one. So I know that velocity final equals, well, I've got actually this stuff. There's a third formula that I can use now. Velocity final squared equals velocity initial squared plus 2 times acceleration, change in distance, which becomes 25 squared equals 15 squared plus 2 times, I don't know, times 125. So whenever I've got this much stuff to do, I always break it up into pieces and write it down as much as I can, because I wasn't good at math. So if I kept it simple, I think I can do it. So let's start with 25 squared. That's 625. 15 squared equals 225 plus, and I can just multiply these two, acceleration times 250. Next step is to move the 225 minus 225 here. 625 minus 225 is 400. So this is gone. And now moving up here, I'll do it in a different color now. Let's do red. 400 equals acceleration times 125. This is a times 125, so I want to do divided by 125. So 400 divided by 125 equals 3.2. So acceleration equals 3.2 meters per second squared. Alright, so I made a mistake. This is supposed to be 250, not 125. So this should be divided by 250. 450 divided by 250. 400 divided by 250 equals, oops, 400 divided by 250. 1.6. That's better. Okay, so I have two formulas that I can use to now solve for time. Which one looks easier? D final equals D initial plus velocity initial time plus 1/2 AT squared, or, well, let's just call it the easier one. So let's plug in our numbers. We have 25 equals 15 plus 1.6 times time. So minus 15, 10 equals 1.6 times time. I need to get this by itself, so I do the opposite function, divided by 1.6, and there's our answer. 10 divided by 1.6 equals 6.25 seconds. Okay, the next part is page 71, number 31. Learning to ride a bike, this person's father pushes him with a constant acceleration for 6 seconds. Then continues, so let's underline that, first portion of info. Then continues at 3 meters per second for another 6 seconds before falling. What is the displacement? So we're trying to find a total distance. Remember, this is a straight line path, so we'll call this displacement total, I guess. But when it's a straight line path, well, distance and displacement are equal. So we need to look for total difference. But here's the challenge. We have a constant velocity and then an acceleration section. So this is in 2 parts. I have to solve part 1 is with constant v. Part 2 is constant a. The constant velocity part, we can use velocity, distance, and time. Velocity equals this one here. Here's the constant velocity. He's just going 3 meters per second for 6 seconds. And solve for distance, which is distance equals velocity times time, 3 times 6, 18 meters. Okay, that's part 1. Part 2 is during the acceleration. During the acceleration, okay, this is first we know velocity initial equals 0. Acceleration equals 0.5 meters per second squared. Velocity time equals 6 seconds. And we actually know velocity final, because after the father was done pushing him, he was moving at 3 meters per second. So that means starting from rest, he was moving at 3 meters per second. That's the final. So do we have everything that we need to find distance? Distance. Well, we have 2 choices. We can use either formula. When velocity initial is 0, I prefer this one. And I'm going to do it where I have some room. Distance final equals distance initial plus velocity initial times time plus 1/2 AT squared. These 2 are both 0. Distance initial is 0, velocity initial is 0, so I can get rid of those. Distance final equals AT squared. Distance final equals 1/2, 0.5 times 3 squared, 1/2, 0.5 times 9, 0.5, combine these 2, times 4.5. Calculator, 0.5, oops, clear, 0.5 times 4.5 equals 2.25. So 18 plus 2.25 is our total distance. That's the last step. We need to add both the movement from each side and combine. Distance equals 18 plus 2.25. Total displacement is 20.25 meters.